Hello friends. In the last video, we are aware about the various introduction about the linked list and in brief about the linked list. In today's video, now we are going to see about the various types of linked list and various operations on the types of linked list. See, as if the definition it belongs to what are linked list? A linked list is a linear data structure in which the nodes make up linked list where the node are the structures that made up of data and pointer to other node. It means it is divided into two different parts. First part belongs to the actual data or element and another part of the node is belongs to the address of the next location. Usually the pointer is called it as the next. Look at the diagram in this slide where the front pointing is towards the head, that is the 5, which is having 5 is a data element, and that whole box is called it as the node, which carries the value along with the address of the next location. This is the basic difference between arrays and the linked list, where in arrays the array is of fixed size as well as linked list is of dynamic in size. We can perform the insertion and deletion are inefficient in arrays, whereas in linked list insertion and deletions are very efficient because we don't have to need any type of shifting in linked list. Whereas in arrays we can randomly access any of the element. It may be at any position, but in linked list it is not possible to access any element randomly. Next, now in this video we are going to see about the various types of linked list. Basically there are two different types of linked list. One is singly linked list and another one is doubly linked list. We are now see in this today's video will give you the brief description about the singly linked list. Now, what is singly linked list? In singly linked list, each node has only one link part. Only one link part. Whereas each link part contains the address of the next node in the list. As I already said, a linked list is divided into a particular node is divided into two different parts. One is of data element and another is of address of the next element. So, address of the next node rather. In this link part of the last node contains the null value, that is the end of the linked list, or we can say that null signifies the end of the node. This is the schematic representation of a singly linked list, in which it starts from it is consisting of 4 different nodes, say A, B, C and D, where the first node is having the address of the next node. A is having the address of B, B is having the address of C, C is having the address of D, and D is having the null address that indicates the end of the linked list. Each node contains the value that is the data, or we can say over here the value is nothing but A, B, C and D respectively, and the pointer to the next node in the linked list. MyList, here we have described it with the name MyList. MyList is a header pointer which points the first node in the list, like this. Initial node we can also say. There are 5 different basic operations which we can perform on the linked list. They are creating a list, inserting an element in the list, deleting an element from the list, searching an element in the list, and reversing the list. See, we'll go with one by one. First is creating a node. If we want to create a particular node, we have to use this type of code first, like struct node, insert the data, node that is next, and then start is equal to null if in case. That is, start points to the first node, initialize to null at the beginning if there. Accordingly, this is the particular code. If we have to generate a node with single element. Say one is the data element and which carries the address, which does not carry the address of the next element because it is the null node, we can say. Next is uh, while inserting a node in the singly linked list, creating the node we have already explained. If we want to insert the node in the singly linked list, they are again divided into three different types or three different cases: insertion at the beginning of the linked list, insertion at the end of the linked list, and insertion at a particular node or at an appropriate position in the linked list. These are the three different cases to insert a node into the singly linked list. How it is possible? How it comes? Insertion at the beginning. See, there are two steps to be followed. If you follow these two steps, you can insert a new node at the beginning of the linked list. Make the next pointer of the node point towards the first node of the list, and make the start pointer points towards the new node. It means we have to change only one address in the linked list because we have to insert the node at the beginning. So whatever the element which is present at the which is present earlier at the linked list, we have to give that particular address to the newly inserted node. Look at the diagram. See, firstly the linked list is of only three different elements, say 3, 6 up to 100. But if I want to insert a new element which is at the beginning of the list, beginning it means 3. If the list starts from 3, we have to insert the new element before the 3. Ultimately, we have to insert say 2 as a value, but that 2 may carry the address of the node which is present earlier. 2 may carry the address of the node which is present earlier. The earlier present element is 3, so ultimately 2 carries the address of 3. This whole node 2 along with the address of 3 is the new node that we are going to insert in the linked list, which is at the beginning of the linked list. See, already there is a linked list which is present, which starts from 3, which starts from 3, but we have to insert it at the beginning, so this 3's address should be with 2, should be with the newly inserted node, because it is inserted prior to the already available node in the linked list. This is the actual code for the linked list for inserting the new node. Next, inserting at the end of the linked list is again the same thing. We have to change the address of the null node, which is already the null, but we have to change that null to the newly inserted node which we are going to insert at the end of the linked list. Here we simply need to make the next pointer of the last node points to the new node which is already a null. This is the code for the same. Inserting after an element, or we can say it as inserting at an appropriate position. If I want to insert a new element at any position, at any desired position, here we need to follow the following two steps that make the next pointer of the node to be inserted point to the next node of the node after which you want to insert the node. It means whatever the node you are going to insert, that value should be that address should be with the previous node, and that the newly inserted value or newly inserted node should carry the address of the next node which you have inserted. Make the next pointer of the node after which the node is to be inserted point to the node to be inserted. Likewise, see, 20 is already there, 40 is already there, up to 100, whatever. But if I want to insert a new element, that is say 30 in between these two, so we have to change the two addresses. The address of 20, the address of the node which is carrying the address of the next element, that is 40, should be changed. That 20, the address which 20 is carrying should be changed to 30. So 20 can carry the address of next newly inserted node, that is 30, and 30 may carry the address of 40. Then and only then we can insert a new node in between this 20 and say 40. Ultimately, we can insert a new node at any position into the linked list. I hope it is clear. This is the actual uh, this is the actual code for the same. Ultimately, at the same time, if we want to perform the deletion operation, we again can delete in these three cases: deleting the first node, deleting the last node, and deleting the intermediate node. Intermediate node means at any position. Same thing we have to apply if we want to delete the first node. We have to follow these two rules or these two steps. Make the start pointer point towards the second node. Delete the first node using delete keyword, as simple as that. Ultimately, the address of the start may get changed to the next different node. This is the code for deleting a node. Deleting the last node, simply we have to change the null address, and we have to give the null address which is there to the last but one node. Ultimately, making the second last node, or last but one node we can say, making the second last node next pointer to the null. Deleting the last node via delete keyword, as simple as that. This is the code for delete. Next is deleting a particular node. Of course, if we want to delete a node at intermediate position, we have to change the address of both the nodes, which is present earlier and which is present the afterwards. Here we make the next pointer of the node previous to the node that being deleted point to the successor node of the node to be deleted, and then delete the node using the delete keyword. Successor node we have to change. This is the simple code for deleting the node at intermediate position. And next operation that we can perform on singly linked list, they are searching. That searching involves finding the required element in the linked list, whereas we can use various techniques of searching like linear search or binary search, or where binary search is more efficient in cases of arrays as well. But in case of linked list, since random access is not available, as if every node is having the address of the next node, so we cannot access any element randomly in the linked list. So it would become complex to do binary search in it. Next, we can perform simple linear search traversal also in singly linked list. This is the various code to find or to find any element or to search any element in the linked list. Next is we can reverse the linked list also. When we can reverse the linked list by reversing the direction of links between two nodes. We can reverse the direction in case of say D can points to C. See, initially input is like A can points to B, B can points to C, C can points to D. But if we want to reverse the linked list, we can have complete contrast the directions of the list, so that D can points to C, C can points to B, B can points to A, and A points to null. This whole reversing the arrangement of elements in a reverse manner is called as reversing the linked list. We can make three structure pointers like this, and this is the code for the same. This is all about in today's video. Thank you for patience hearing.